Good evening. In this session, I am going to explain you some more problems based on center of mass, angular momentum and torque. They come under the topic system of particles. So, already we have done so many problems on these topics in PYQs. So, you might be very thorough. So, you have to do the problems very quick in this session. Follow me carefully. See here coordinates of a particle are given as 1, 1, 1. So, its position vector is I bar plus j bar plus k bar. On that particle, a force of I bar minus j bar plus k bar is applied. What is the magnitude of the torque on that particle in z direction? So, torque is equal to R bar cross F bar. So, torque is equal to in determinant of I, j, k, 1, 1, 1, 1 minus 1, 1. Okay. So, torque is equal to I bar into 1 into 1 minus of minus plus 1 minus j into 1 into 1 minus 1 minus 1 plus k bar into 1 minus 1 is minus 1 minus 1. So, minus 2. So, torque is equal to 2I, 1 minus 1 is 0, minus 2K. That is the expression for the torque we got. But here you are asked to find the magnitude of the torque along y axis. So, magnitude of the, not along y axis, along z direction. So, magnitude of torque along z direction is the positive coefficient of k bar. So, the positive coefficient of k bar is 2, hence the answer is 2. Go to the next problem. Look here. See, this is a uniform thin metal plate, mass is given, coordinates are given. The ratio of x coordinate of center of mass of the plate to y coordinate of center of mass is given as n by 9. You are supposed to find the value of n. So, here as this is that is a uniform plate that is mass is directly proportional to area, length into breadth, like that if you take the rectangular portion. Let us consider these three portions separate. 1, this is 2 and this is third portion. So, for the first portion, mass is 2, length into breadth. This is 1, this is 2. So, this is 2. And for the central portion, this part is 1 and this is 1. 1 into 1, its mass is 1. And for the next part, again this is 1 and this is 2. So, 1 into 2, 2. And this is taken as the origin. Here the most important thing is identifying the centers of mass of the individual portions. This mass is taken as 2, center of mass coordinates. It is at the center. So, x coordinate is 0.5 and y coordinate is 1. Next, this is 1, mass is 1. For this is the center of mass. X coordinate is 1 plus 0.5, 1.5. Y coordinate is once again 0.5. Y coordinate is this 0.5. And for this, mass is 2 and x coordinate is this, that is 2.5, and y coordinate is this, that is 1. So, xCM, x coordinate of center of mass m1 x1, that is 2 into 0.5 plus m2 x2 1 into 1.5 plus m3 x3 2 into 2.5 divided by total mass 2 plus 1 plus 2, that is 5. 2 plus 1 plus 2, that is 5. So, this is 2 into 0.5 is 1 plus 1.5 plus 5 divided by 5. So, here 6.5, 7.5 by 5. So that implies x coordinate of center of mass is equal to 7.5 by 5. That is x coordinate. Let us find out y coordinate of center of mass using the same kind of formula. m1 y1, 2 into 1, that is 2. m2 y2, 1 into 0.5, that is 0.5. m3 y3, 2 into 1, that is 2, divided by total mass m1 plus m2 plus m3. So y coordinate of center of mass is 4.5 by 5. So x coordinate of center of mass to y coordinate of center of mass ratio. See, from this it is 7.5 divided by 7.5 by 5 by 4.5 by 5. This and this gets cancelled. So, but our option is given in terms of n by 9. So, if you multiply with the 2 and divide that with 2, you got it as 2 7.5s are 15, 2 4.9s are 15 by 9. So, the ratio of x coordinate of center of mass to y coordinate of center of mass is 15 by 9, but it is given as n by 9. So, in place of n, we got 15 here. So, the answer for that question is 15. Okay? Move on to the next problem. Look here. In a system, two particles of masses 3 kg, 2 kg are at a certain distance from each other. So, this is 3 kg and this is 2 kg. The particle of mass m1 moves towards m2 through a distance 2 centimeters. What is the distance moved by the second particle so that there is no shift in center of mass? Center of mass lies at the original position even after the movement of the two particles. So, here the formula for shift in center of mass is delta x cm is equal to m1 delta x1 plus m2 delta x2 by m1 plus m2. Here, even after the displacement of the two particles, the center of mass remains at its original position. So, shift in center of mass is 0. So, this is given as 0. Then it implies m1 delta x1 is equal to minus m2 delta x2. That negative sign indicates as the first particle moves in this direction, the second particle moves in the opposite direction. So, from this you need to find out delta x2. So, we can drop that negative sign because that merely indicates the direction. He asked us to find the distance through which the second particle is moved. From this delta x2 is equal to m1 3 delta x1 2 divided by m2. So, this and this gets cancelled, it is equal to 3 centimeters. So, the answer for that is 3 centimeters. So, here shift in center of mass is 0, then m1 delta x1 is equal to minus m2 delta x2. Look here, the identical spheres of mass 2m are placed at the corners of right angle triangle with mutually perpendicular sides. Let us draw the diagram for that. 3 identical spheres of mass 2m. This is of mass 2m, this is of mass 2m. They are placed at the 3 corners of a right angle triangle. Mutually perpendicular sides are 4 meters each. Okay, magnitude of position of center of vector from one of the corner. From this, let us take this as the origin. So, distance of center of mass from this point is asked here. So, here let us write the coordinates. For this particle, let us name this as O, A, B. So, the coordinates of O, mass placed is 2m, and coordinates are 0, 0. At A, mass placed is 2m and the coordinates, x coordinate is 0, y coordinate is 4. And for B, mass placed is 2m, x coordinate is 4 and y coordinate is 0. Okay. So, xcm is equal to, actually as all masses are same here, we can take them as 1 each. Okay. m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, that is 4 by 3. Similarly, y coordinate of center of mass is m1 y1 is 0, m2 y2 is 4, m3 y3 is 0, it is 4 by 3. Both x coordinate and y coordinate are equal here, it is just equal to, we can write the position vector of center of mass is 4 by 3 I bar plus 4 by 3 j bar, or its magnitude is 4 by 3 root 2, because root of 4 by 3 square plus 4 by 3 whole square under root. So, it is 4 by 3 root 2, but it is given as 4 by x root 2 in the question. So, in place of x, we have 3 here, that is what we need to find in this problem. Okay. So, move to the next model. Look here. A body of mass m is projected with a speed u making an angle 45 degrees. Find its angular momentum with respect to the point of projection at the highest point. So, actually angular momentum is expressed like this, you need to find out x here. So, we have done the problem of same type in yesterday's class also. At the highest point, linear momentum is mu cos theta, it is along the horizontal. This is the point of projection. The perpendicular distance of linear momentum about the origin is h. So, angular momentum when it is at the highest point is mu cos theta. Maximum height reached by a projectile is u square sin square theta by 2g. So, here angular moment, this is linear momentum, isn't it? Angular momentum is r cross p, that is u square sin square theta by 2g into mu cos theta. So, angular momentum at the highest point of a projectile from this is half mu cube sin square theta cos theta by g. Right? Here only thing that is given is angle of projection. So, here it is half mu cube by g, sin 45 is 1 by root 2, sin square is 1 by root 2 square, 1 by root 2 square, and cos 45 is 1 by root 2. So, this is root 2 square is 2. So, 2 2s are 4, 4 root 2. So, this is 1 by 4 root 2 mu cube by g. This is the angular momentum at the highest point we got, but they gave it as root 2 mu cube by x into g. So, these two are equal, say we need to find out x. Mu cube by g, mu cube by g gets cancelled. So, x is equal to 4 root 2 into root 2, that is equal to 8. So, the answer for that is 8. See, if you watch the numerical problems, the concept and everything is simple, and the last one you have to compare our value with the given expression to find the unknown in the integer form. Okay. Now, look here, a body of mass 5 kg, mass is given as 5 kg, moving with a speed 3 root 2 meter per second in xy plane along the line given by y is equal to x minus 4. The angular momentum of the particle about the origin. Right? See here, the formula for angular momentum is L is equal to R bar cross P bar is equal to mv bar, or L is equal to mvr into sin theta, where theta is the angle between them. Look here, let us draw a diagram. See, this is x-axis and this is y-axis, so that represents xy plane. It is moving along the line given by y is equal to x minus 4. We know y is mx plus c is the equation for a straight line. So, this is the direction of velocity. Along that straight line, the particle is moving. So, here this angle, the slope, tan theta is equal to 1, hence theta is equal to 45 degrees. And this is the negative intercept, that is 4. So, this becomes r. So, its velocity is in this direction, momentum is also in this direction. The component of momentum along this will be mv cos theta. Actually, component of this along this side. So, we can, that is equal to 45 degrees. So, here angular momentum is linear momentum into perpendicular distance. So, mv cos theta into r, that is 4. So, here mass is given as 5, velocity is given as 3 root 2, cos 45 is 1 by root 2, r is given as 4. Right? So, here the answer becomes 5 3s are 15, 15 4s are 60. See, in this I wrote it as mvr sin theta. You may get a doubt why I wrote this as mvr cos theta. It is simple. Suppose if you want to write this way, this is r bar and this is v bar, angle between them, this is equal to theta, then that expression becomes mvr sin theta, where if this is the angle considered. Is it okay? So, here from that, okay, so here L is equal to 60. Move on to the next problem. Look here, a force of minus p k bar acts on the origin of the coordinate system. Force is given as minus p k cap. The torque about the point 2, 3. So, r bar is equal to 2 I bar minus 3 j bar. Okay, so it is given as torque is given as P into AI plus BJ. Your ratio of A by B is given as x by 2, supposed to find the value of x. So, look into this question carefully. F is given to you and R is given to you. We need to find out torque. So, torque is equal to R bar cross F bar. I cross K is minus J. Minus of minus becomes plus. So, plus P J bar. J cross K is I. So, minus into minus becomes plus. So, plus 3P J cross K is I bar. Okay. So, I cross K is 2, I cross K is J, 2 into P, that is 2P, right. So, here we got the torque expression as P, if you take that P as a common factor, 3I plus 2J. But they gave the torque as P into AI plus BJ. If you compare these two, A by B, A is 3 here, B is 2 here, 3 by 2. So, we got A by B as 3 by 2, but they gave A by B as x by 2,